Soil properties. In this chapter, we're going to learn the basic about soil. Soil is the naturally occurring and consolidated or loose covering on the earth's surface. I've never seen any artificial soil before except for landscaping work. They use artificial soil for decoration purpose in the pot. Soil is made up of broken particles that have been affected by processes such as weathering and erosion. Soil particles can be loose or compacted. The nature of the soil is different, depends on weathering and environment changes. We will discuss this later and also in different chapters. Rock is hard and needs certain processes such as drilling and blasting to break it into smaller forms of particles. Soil can be divided into several layers. For example, in this figure you can see it has organic layer, topsoil, subsoil, parent materials, and bedrock. The topsoil is the top layer of the soil, which normally we removed in the construction site because it is loose and it's not suitable to bear the load. The thickness is between 150 to 300 mm. It depends on the condition at the site. So you will normally see this in the PQ or when you learn about quantity surveying, where it says excavate and remove the topsoil. The topsoil contains the debris, organisms, and decay particles and plants. And the middle part of the soil, it depends on the erosion and rock formation. And the bottom part of the soil is what we call the bedrock, or some people say it's hard rock. So bedrock can be a compacted and a compacted soil which can bear the load, or it can be rock. It depends. And another figure, as you can see in the slide, it divides those layers of soil into horizon, like O horizon, A horizon, E horizon. And if you open different kinds of civil engineering books or soil mechanism books, you can find probably a little bit different of the layers of soil. However you see the layers of soil, it will tell you that it has the top layer and the middle layer and also the bedrock. These are the three important layers in the construction. Soil can be formed into from different processes. For example, here it says transport soil. So soil can be transported from wind or water. If you realize, sometimes if you go to the river, Malaysian people like to go to river, and maybe this year if you go to that river, it's really deep, and maybe after a few years you go to the same river and you find that the water getting shallower than before. So that means the soil has been transported by the river, and normally they will use dredging to increase the depth of the river. Residual soil is where the soil is formed by decomposed process on the rocks, which transform it into smaller particles. And organic soil is formed by decayed plants and animals, dead animals and plants of humans. It will form back into the soil, and it's rich in minerals normally. Rock formation can be formed by three major processes. The first one is igneous rock. Volcanoes produce igneous rocks such as granite and parmesan and obsidian. Second one is sedimentary rocks. It is formed when all the rocks are broken apart by plant roots and earth movement and become transported by glaciers, wave currents, and wind. bound together as secondary minerals, sandstone, limestone, and shale. So normally when it bound together as secondary mineral, do you know the primary and secondary minerals, sometimes the bond is not strong. So the secondary rock tend to slide because it forms on the primary rock. So limestone, for example, we have caves, you know, on the on the highway from KL to the north, you know, that highway. The Plus Highway, if detected that there will be rock slide. It's not landslide, but it's rock slides. So they've closed the part of that highway once they detected the early signs that the rock will slide, and it's because of the secondary rocks which formed onto that primary rocks will lose. So after a few hours, I think, then the rock really slides and onto the drive highway. Right, the last one is metamorphic or crystalline. It forms when pressure and temperature is really high, and it formed quartz, marbles, and slates. Soil can be divided into two different types, cohesive or non-cohesive soil. Cohesive soil in Malay is called berjelikit. Non-cohesive means it's not berjelikit. Jelikit means it's liquid, and non-berjelikit means it's not liquid macam tanah liat, okay, dia liquid, and non-cohesive is not berjelikit, like pasir. So you pegang macam mana pun dia tak melekat dekat tangan. So cohesive soil, the size is very small. It's less than 0.06 millimeter, and the sand, non-cohesive soil, is more than 0.06 millimeter. Sometimes it's more than 200 mm. It can be, you know, the crushed iron is considered as non-cohesive soil as well. So it can be small and it can be big. So if you realize, you know, when you have dry weather in Malaysia, and especially on the road, you know, the laterite roads, the tanah yang kuning tu, especially dekat kelapa sawit, oil palm farm. So if you drive through, sometimes you can have the debris coming up because the particle is small. So you have the debris like debu. So if it goes into your eyes, you can, you know, it's fine. The texture is fine because the size is less than 0.06 mm, as considered as to sand, it's more than 0.06 millimeter. So if sand get in your eyes, you will feel really painful. And if you scratch it, like if you gosok mata, it will, you know, harm your eyes as compared to cohesive soil. Kalau debu masuk mata, it's not as painful as pasir masuk mata. Well, water content is high in cohesive soil, and water content in non-cohesive soil is low. That's because in non-cohesive soil, let's take the sand, okay? If you pour water on the sand, it will quickly dries up because the particle is not melekat to each other. It's loose. It's not holding each other, so it has space, it has pores, so the water flows easily to beneath, to you know, to below layer. And for cohesive soil, if you put water, then it will absorb, because the particle is small and it contact to each other, it holds to each other, and it becomes berjelikit. Excavation for cohesive soil is hard, especially when it's dry. So when it's dry, it tends to compact, like it's like compacted soil normally, especially if you have rain. After a few times, it get naturally compacted. So for example, in Puncak Iskandar, we have the type of soil here in Puncak Iskandar is a mixture between rocks. It has a lot of rocks. If you drive through around here, you can see some rocks at the site above Puncak Iskandar. We still have some of the rocks. You can see that. And the soil itself is hard. So the contractor told me when they did the excavation, it was really hard, and they thought it was the rock, but it was not. It was the soil which has been compacted, and it was during that time the season was hot, so the water dries up and the soil become really hard, so it was hard to excavate. Whereas if you go to a beach, for example, then I'm sure you have played with the what do you call sand castle, okay, and you create sand castle and you put the sand in bucket and then you build your castle. Okay, so it's really easy for you to excavate the soil, right? With your hand or with scoops, and you can just excavate. But when you excavate, you need support. It's different from cohesive soil because it's delicate, it can hold its friends, the particles it's holding to each other, but non-cohesive soil is not holding to each other, so you need support, macam papan, something, so that the rest of the soil wouldn't slide in the excavation area. How can I give example? For example, this is just a metaphor. I'm sure you have, when you were young, when you were kids, you played with beras, rice, in, I don't know, in the apa tu, guni kan, kalau dekat TF ada kat dalam guni, or in the packet. So when you scoop with your hand and beras tu akan jatuh, you scoop lagi, beras tu akan jatuh. So it's something like that. So you need support for the non-cohesive soil. So the types of cohesive soil, for examples, are the clay, peat, and laterite. The particles is sticky, as I've mentioned. And for non-cohesive soil, it's gravel and sand, and the particles are not sticky. Grain size. The coarse grain non-cohesive, fine grain cohesive organic soil seeding and sedimentation methods are used to determine and divide grain size. You have learned these last semester in material subjects, if I'm not mistaken, where you need to mix the concrete, and when you do plastering you need finer sand, but when you mix the concrete you need different size of soil. Moisture content only apply for cohesive soil, clay and slate. So if you've seen the video I've given you on Prop Macintosh, at the end of the Prop Macintosh, you need to collect the sample of soil, and we use oven to measure the moisture content. So if you take sand, because sand, the water flow is easy. So moisture content normally we use for cohesive soil. Groundwater. Definition: water contents under earth or soil surfaces. Rainwater which absorb through crack or narrow gap in soil surface up to 12,000 meters below original ground level. So moisture contents in the soil itself for cohesive soil, it depends on 4 factors. You may have more factors, but here we only teach you four factors. So when you do Proba Macintosh, I will ask you to record the weather. Like if you do it, if your lab is on Monday, I will need you to check the weather before, like Sunday, Saturday, and Friday. If it rains before that, means you will have more water in the soil when you do your Prop Macintosh. But if it wasn't raining before you do your prop Macintosh, you will have drier soil. Okay, and when you go to the, if you see the video, because you know during this time you're not able to do the field work, so if you look at the video, on La La Land we have different profile of soil. So we have slopes, we have trees, like big trees, and like I said just now, the weather, and also the gap in soil. So slope, if you make how do I say, if you make a test on the slope, you will have less moisture content. So the lesser the slope, the more water moisture, because if you have slope, then the rainwater or surface water will just flow through that slope and go somewhere else. So that surface wouldn't contain that much water, as compared if you have flat land. If your land is flat, then the water tend to stay on that flat land, and the soil will absorb more water, so you will have more water. So the lesser the slope, the more water or moisture. And if you have plants, the lesser plants, the more water or moisture, because plants, you know, it holds the particles of soil and it absorbs water for its own use. And you have trees because of the leaves on top, like canopy, right? You have heard of canopy. And in Malaysia, our forest is, we have how many layers? 3 layers. So we have the canopy at the top. So when it rains, it's kind of you know, protection, like you use umbrella. So it's kind like umbrella, where it actually protects the surface from having too much water. So the lesser the plants, the more water you will have in your soil. Weather, total rain, and daily temperature, like I've mentioned. So if you have, like when you do the prop Macintosh, one day before that it rains really heavy. So when you do prop Macintosh, probably it's easy for the rods to go in, because the soil is soaked up with the rainwater. So if it rains, then you will have more water. Narrow gap in soil will absorb more water. So if you have gaps, like, do you know when it's really dry, when the weather is really hot, so for cohesive soil, you may have land which have cracked, kan, sebab dia panas, so the land tend to crack. Pernah tengok tanah merekah kan, because the water has evaporate, and that tanah kind, how do I say, it shrinked. So when it shrinks, so it will have gaps, or maybe due to other reasons you will have gaps in that soil. So when you have gaps, air boleh masuk in that gaps, and thus you will have more water. Effects on construction. High water table will cause instability on earth's surface and soil structure, dangerous to buildings. So if you have high water table on your soil, so your soil will be, how do I say, like lembik. So it you know, because the properties, it's disturbed. So it's dangerous to the building, because if you have structure, for example, pad foundation, and if you rest on tanah yang lembik, probably dia boleh jadi ada settlement. You may have settlement of in your building. Water pressure on building foundation cause cracks, collapse, and sedimentation. So water pressure. So if you have water flowing through underneath, it can happen. It can disturb your building foundation. It can make your foundation crack, because foundation is a rigid structure normally, except for some countries I've seen in Japan, their foundation, they have like suspensions. That is a different story, but foundation is normally rigid. So when you have disturbance, especially water pressure, it has pressure, kan? especially kalau dia lalu on a very narrow gaps. So the pressure will be high and it can disturb your building foundation and it can cause cracks. So when it cracks, meaning the loads will not be transmitted further down. So it will stop at the crack. So the reading will be 0. No load will be transmitted. Then you will have settlement, like I've mentioned before. Settlement of soil due to increase in infective stress. The soil collapse from the weight of the house. So the house is heavy and your soil is not strong. So you will have settlement, dia mendap. It can be even settlement, dia mendap sama cantik, or uneven, dia mendap sengit. Like Eiffel Tower, dekat Teluk Intan Tower tu kan, dia ada mendapan tanah, dia jadi sengit bangunan tu. Okay, so mendapan tanah can not only be due to water, it can be some other factors as well. And drainage, I think you have learned last semester about drainage. Drainage is important for you to transmit the water, the rainwater, surface water from one area to another area and to the river. At the end, it will go to the river. So if you do not have proper drainage, these will cause high water table around your house. So go back and check your house whether the perimeter drain is proper or not. Otherwise, it can do harm to your building. So if you do construction in basement, we will learn more about dewatering. So you need to take out the water. And excavation work need extra support because the water is high. The soil is high in moisture. So you need to have support. Okay, we are still discussing about groundwater. We have saturation zone and aeration zone. Aeration zone. Saturation zone means it's saturated, it's maximum, the area where all the pore space in the ground is filled with water. So if you can see in the figure, the groundwater zone of saturation, meaning all the pores, it's saturated, dah penuh padat with water. And aeration zone is the area where the pore space is mostly empty or full of air. Water table, the level below which the ground is saturated. So because it has pores, it has space, so the water easily flows from that aeration zone to the zone of saturation, and you will have like something like floating piece of land where you have loads of water underneath. Okay. Characteristic of soil. Soil, if you want to know whether it's cohesive or non-cohesive, we can do different tests. The first test is compressibility. So the compressibility of soil is the change of soil as a response to load, pressure, or stress on its surface. So if it's easily compressed, meaning it's cohesive soil, because non-cohesive soil is not easy to compress. It needs vibration. Permeability of soil is a measure of the ability of soil to transmit fluids. It is of great importance in determining the flow characteristics of underground water. If it's permeable, means the water is non-cohesive. Tapi kalau if it's not permeable, meaning it's cohesive. Plasticity is the condition where the soil starts to exhibit plastic behavior. A thread of soil at its plastic limit when it is rolled to a diameter of 3 mm and crumbles. So for this we have tests like I think it's Atterberg limit test and Proctor test. The soil exhibits plastic properties Soils with high plasticity tend to be clay. Those with lower plasticities tend to be silt, and those with plasticity or zero tend to have little or no silt or clay. So if you rolled it, pernah main plasticine kan? If you rolled it, dia jadi panjang macam tu, meaning the plasticity is high. But when you rolled it and sampai 3 mm, dia putus, it crumbles, meaning the plasticity is low. So it's something like you played plasticine masa sekolah tadika dulu. I'm sure you played with plasticine kan, roll. So dia jadi panjang sampai nipis-nipis, sampai halus boleh jadi. Like mi pun boleh jadi. So the plasticity is high. For example, like mi, orang buat mi boleh tarik-tarik. So the plasticity is high. Uses of soil. Among uses of soil in the construction works, we use soil, sand, for concrete or plastering. You have learned on how to mix the concrete. We have different ratios for concrete mixtures and different ratios for plastering work. You've learned this in semester 1 if I'm not mistaken. And you've learned in the site survey about land, cut and fill. So we need soil to fill some spaces, or sometimes we need to take out the soil from some other spaces because we want to have a space. For example, you want to build a basement, so you need to take out the soil, and maybe you can use the soil somewhere else which need the soil. And the third one is reclamation. Reclamation is a construction technique or procedure where you can have more land than sea. For example, in Malaysia, we have Malacca Gateway. In Dubai, we have the Jumeirah Palm. We have many reclamation works in Malaysia, in Johor, in Perak, in Malacca, in Terengganu. So what they do is they transport soil from different places, and they, if you can see in this picture, Malacca Gateway, so they make like Dubai palm, Jumeirah palm, they have the shape of palm tree. In Malacca Gateway, they also have design, and they have in Marina Bay, in Pangkor, if I'm not mistaken, they have this reclamation work, and we can have more land. Oh, we have a controversial reclamation work project in Penang, so you can do your own study or more information about that on YouTube. You can see that on YouTube. So if you can see here, this is how they transport the sand. This is the technique. It is called rainbowing, where it shoots out the sand that they have dredged earlier. So I think you should read more and see more of the videos yourself on YouTube. I will recommend these videos on your Google Classroom stream. Okay, I will give you the links and recommend you. So beach reclamation works. The purpose of beach reclamation is to protect development properties from storm damage. Do you know sea can be damaged? Like in Maldives, I also know they do reclamation work to protect their sea from storm damage. Extend beaches for public use, like in Malaysia, most of our reclamation works is for public use. They make hotels, port, and to re-establish sandbars. Also protection from storms, daripada terhakis. So maknanya dia nak avoid pantai tu daripada terhakis, dia buat reclamation. So it's like sand breakers. Here she says reclamation becomes source of replacing the speed breakers, and dredging is the most common means to replace them. I'll go to dredging on the next slide. It's just a simple basic knowledge on dredging. So breakers means dia letak macam lapisan supaya laut ataupun storm tak hakis river banks or the beach. Okay, so it's breaker macam buat Jumeirah Palm and also the Malacca Gateway. They also have breakers when they do the reclamation works. And reclamation itself, when you do kalau extend the beaches for public use, that extension can also be part of the breakers daripada dihakis yang asal. Okay, how it is done. Beach reclamation is often done through a process called dredging. Dredging is the process of scooping from the bottom of water source a material. In beach reclamation, the material retrieved is sand. You can have dredging for different types of soil. Macam kalau kat Paya Bakau, if you do dredging, you will get different types of soil. Sebab kat Paya Bakau, dia punya tanah adalah aggressive soil but very disturbed sebab dia punya moisture content is really, really high. Once the sand is obtained, it is deposited at the site. Macam gambar yang I showed before, rainbowing, they shoot out the sand. Sand is either directly applied or the sand that has been gathered is cleaned through a heat process and then deposited. I'll show you some pictures. So for dredges techniques, we can divide it into two different types of dredges. The equipment, I'm talking about the equipments now. And when you use different equipments, meaning the technique will be different. So this one is mechanical dredges. The first one is bucket ladder dredge. So if you can see here, it's like a chain of buckets. So can you see the bucket here? So when the chain moves, the bucket will go, it's like the shape is something like this, and then it will go diagonally underneath the sea, and it will scoop, that bucket will scoop the sand, and it will bring up the sand into the storage ataupun into the barge. That is one, it's called bucket ladder dredge. And the second one is grab dredge. This one, this is normally used at the river as well. So dia macam grab, dia you take your hand and you just grab something. That's how it grabs. That's why it's called grab dredge. Cuba ambil you punya tangan, you peganglah botol ke apa ke, dia macam tarik, dia korek daripada bawah, macam dia genggam tanah tu. Okay, and it grab the soil underneath, I mean in the sea, and it will take out and put it in the barge or some other storage, whatever they have. This one is called dipper and backhoe dredge. So dekat sini nampak is the backhoe. It will excavate the soil underneath and it will take out. This is like normal excavation. Okay, then it will just the same thing, store the sand. The second one is hydraulic dredges. Hydraulic dredges only show you two types here. You may find different types on new technologies as well. So the first one is what we call plain suction dredge. So this one, this dredging is this dredger is floating. Okay, so it has the suction rod, and it will suck the soil to the barge, to the storage. So it has sucked here, so it's called plain suction dredge. Macam sedut pakai straw, macam tu lah lebih kurang. So it has pump and everything. So this is cutter dredge, this one on your right, the picture here. So the cutter at the front of the machine, you have cutters. So you have different types of cutters. It depends on the type of soil in the sea. So this one, yang ini, the red one, it will go underneath dalam air and it will move left and right. You can see YouTube videos. Left and right, they will have anchors to control the dredge, and they also have like a suction machine, and they will suck the soil that have been cut onto the barge ataupun onto the storage. Okay, that's all I think I have. Sorry, that's all I think I have for the basic of soil or soil properties. We will learn more about soil in the next chapter. Thank you.